Okay, so,
What principles?
well, first off, here's the diagram.
Principles are just say,
Energy.
yeah, energy and momentum, possibly. No air resistance, no friction.
Heck yeah. I like how fast we're going through this. Although, because I hate to be a Debbie Downer, but because they taught us air resistance, should we do air resistance?
No.
Thank you. All right, let's not do it. Okay, put my notes up.
I'm glad we agree.
Cool.
Well, it does say estimate the speed it's launched into the air. Oh, never mind. That's like right when it's launched.
Yeah, there won't be any air resistance at that point.
Also, I don't think we can calculate air resistance because we don't know the shape of the block. Could be a spherical block.
So do we want to say the block, the spring, and the earth are the system, and the surroundings is the ramp, or?
Oh, yeah, we can
What
put.
it says.
Yeah, we can put everything in the. Yeah, you're probably right.
It says,
Or no?
it says anything experiencing a change, so I feel like that would just be the block because the spring and gravity are causing the change.
Oh, I was just thinking since we're using, or we want to use
Energy principle.
energy principle that we.
We can do.
I mean, it's
we
either
can do
way.
work. I mean, it's the same thing.
And then you can,
Because any,
yeah.
it'll just turn
Would
into
it be
work.
would it be easier to do all of them in one?
I don't think it would make a difference because it's just going to be which side of the equation do they start out on.
Okay, that's fair.
So
You can do whichever.
we can do anything experiencing a change for as the yeah. Let's just do the block as the system. Surroundings will do spring, earth, and then honestly those are the only things causing this change because there's not really a force of the ramp.
Well, the ramp is
I mean,
causing
there
the
is.
angle, though.
Yeah.
Okay, so we have.
Does it want estimate the speed at which the block is launched?
So there's no
into
actual
the air.
like numbers in this. So we can write out like we should like write out the energy of the block right when it's about to be launched.
Okay.
So total energy.
Energy equals. Well, I guess work. So. Ooh. So.
Can I? Wait. No. Yeah. Yeah. Connect plus the gravitational potential plus the.
In
spring
this
potential,
instance,
right?
In this instance, potential would be 0, and work would be all of those potentials that are changing. So we have kinetic, final, minus the kinetic, initial, minus 0 for the potential, minus 0 for the initial. And the gravitational potential or work is minus shoot,
It's
guys.
just gonna be F net, so wouldn't it just be F spring?
We'll just go F gravity.
Minus.
Plus the force of the spring.
Yeah.
So that change of potential energy, that's just of the spring, or what did you do there? That's just the.
Yeah, for the how did you get the zeros again?
So when just talking about the block technically doesn't change its potential energy, it's kind of funky when you talk about like just a single object system, because the gravitational potential energy, that's actually work being done by gravity.
Mm-hmm.
So if we're just
Oh,
looking
I
at the
see.
block as the system, this is why I got all the stuff wrong on the quizzes, because like when it would just talk about the horse as a system, those always messed me up. But I'm pretty sure when just dealing with the block as a system, its kinetic energy changes. It doesn't really have potential energy, but the work done would kind of be potential energy. But if you're just looking at the block, then it's work, not potential.
Okay, so the two
I don't know.
zeros is the zero or the final potential energy minus the initial potential. Those are
I
both
mean,
zero.
I could just.
Okay.
You know, I could just. This would be easier. Plus.
Because in high school, I remember doing I remember a block or an item has potential energy, gravitational potential energy, and kinetic energy, but I don't know. You made like the point that gravity does the work, but wouldn't that only be gravity doing work, but like the potential energies of the block? Do you know what I'm saying? Because
Or,
I think that applies to work done. So the work is done by gravity, but the object has potential energy because it has some height. Because that energy is not contained in gravity.
God, this is why I
It's
always hated.
in the block.
Okay, let's just make everything the system and make nothing the surroundings. Because this would make it so much easier. So, final kinetic energy. Okay. So, 1/2 mass times velocity squared plus gh is the final one minus 1/2 kx squared. Or I guess out would be whatever. So more specifically, K, what is x? X is L0 minus L.
Mm-hmm.
Also, wouldn't the spring potential energy be positive? Oh, never mind, because you're stretching it, right? No.
What?
The block isn't attached.
Yeah. What?
So I don't think at that point we have any spring potential energy.
At the start?
So I think like you press the block down so that the
Mhm.
string compresses, then you let go, and that launches the block.
Yeah.
And at the very end of the ramp, when it's about to launch, it's
Mhm.
not in contact with the spring.
Yeah. That would be the final. So there the only energy is gravitational.
Okay.
That's what the yeah, so initial potential energy is all going to be spring.
Yeah.
And then
Okay.
the final one is all
'Cause it has no height.
Mm-hmm. Yeah. Or it can't get any shorter, I guess. I don't know. Something like that.
Yeah.
I'm kind of spitballing. So.
Wait, do we need to change height using theta? Do we need to find
yeah,
height using theta?
Yeah. Because theta. Well, we need actually the length. The spring is also equal to the total. Oh, okay. So length is okay. All right. So the height equals. Oh,
Actually,
gosh.
I think we're calculating it at the very top of the ramp when the block lets go.
Equals height over L0. What?
I think we should
Wouldn't it be sine? Sorry. 'Cause sine is opposite over hypotenuse.
Yeah, no, sine is opposite over hypotenuse. I don't know what you're talking about. Yeah. Boom. You're correct.
Okay, so I don't
Okay,
think
so-
we should have a potential energy for the spring,
At all.
because in part 1 we're just about to launch.
So the reason why we're doing the potential energy is because we're finding the velocity using the energy equation, and we find that because when the spring is compressed, there's no kinetic energy and it's all potential energy. But as you remarked, when the spring is not compressed, it's just kinetic energy and there's no potential energy. There's a little bit of gravitational energy, but we'll deal with that. And so we know that there's conservation of energy, so we can set the potentials equal to the kinetic, and
Sorry.
so
Makes sense.
so the spring potential energy is important because we're using it as the initial potential energy. So
Sounds good.
K times L. Oh, whoops. Okay. What does everyone have? Did someone...
That is what I got. Oh wait, your L not minus L needs to be squared, I think.
Oh, you are correct. Thank you. I did that for the entire problem. Cool.
Okay, I agree. I got the same answer too.
Cool.
One sec.
Now you're good.
Yeah, okay. I got the same thing.
Okay. Well, that's part 1. Predict the time for the block to reach the highest point on its flight.
That's when velocity equals 0.
Mm-hmm.
Right.
So you have to use velocity equals distance over time, and you have to solve for time there? Or... No, wait, no.
Distances. X equals... let me see. Go notes. Well, now that we have velocity, we might be able to use the momentum principle somehow. Gotta find it though.
Yeah, can't you just use the change of momentum is equal to F net delta T? And since I think your initial momentum is 0, because it's just sitting on the spring, right?
Mm-hmm.
So you already have your speed for when it's going to go off. So your P final is just m times the speed we found. Set that equal to F net delta T. F net is just the force of the spring plus the force of gravity, or minus.
Actually, so
No.
if we have the velocity, wait, velocity is a vector.
Mm-hmm.
We found a scalar. This is a scalar.
Mm-hmm. Mm-hmm.
So this is really speed. Okay, so yeah, it does say estimate the speed. Okay, so we need to break this up into two components, a y component and an x component.
And this is where we're going to use theta.
Because it's currently launched at theta angle.
Mm-hmm. And so you can turn that into a vector pretty easily. Just doing sine and cosine.
I'm glad you know how to do that. Why is this all bolded? I want this not bolded. Okay. What is it? V cosine theta? Is this how you do that? I'm kind of stupid.
Yeah, and then v sine theta.
0. So it's when
A diagram?
Oh.
so the entire time. Also a equals. Okay, why is this all freaking bold? Stop. Okay.
Wait, it's for part 3 and part 4 also.
What?
The diagram and everything under it.
Oh, draw a diagram. Oh.
Yeah.
Diagram. Let's
I don't know what to draw, just like a parabola?
yeah, I guess so. Unfortunately, I don't know how to draw a parabola.
It's a rainbow.
Ooh, that was almost good. Oh my god, look at this.
Beautiful.
What a perfect parabola.
Perfect rainbow.
I can't put theta, so I'm just gonna put ang.
So for the last one, we didn't need the momentum principle.
Yeah, we'll fix that.
Beautiful.
Thank you. I'm going quickly so we can stop working on this as fast as possible.
But I like the spirit.
Sorry, guys.
Are we doing air resistance in this one?
Shoot,
No.
dude. Probably not. I'm gonna see how long we can go without doing air resistance.
Oh wait, guys. This is
Don't
Part
do this
two.
to me. Don't.
no. Bro, this is good news. Part 2 is easier than I think we originally thought.
Yeah, it's
Can you just
part 3 is even easier.
Yeah, no. What we just divide sine.
We just solve for
sine junky junk by gravity.
what?
What? Sorry. What
Can't
were
we
you
just find? Can't we just find when velocity equals 0 and then divide it by 2? Because that's when it's hit the ground.
Yeah. Well, velocity won't. Oh well, no, you're right. You're right.
That's
but
actually pretty smart.
when velocity
Wait.
equals
0. Because then it'll have hit the ground.
unfortunately,
I don't know how to ramp fix that.
shit.
Don't ask me.
This
I'm
is
hoping it doesn't.
okay. Give me a sec. Give me a sec. I'm gonna fix this drawing or copy paste it. Momentum, principle, assumptions.
Wait, so how come you would divide the when the velocity is equal to 0 by 2?
Okay, so it's the time. Okay, so if you find the time that it takes for the entire thing to happen, from start to finish, once
divide by 2
then
is
you
just
divide by 2,
halfway.
gets halfway
Okay.
on the parabola.
Okay. Got it.
And so to do that, we need to find, well, first off, we need to get a proper gravity vector, gravity velocity. We really need an equation. Why can't we just, can we, what is it? It's, I'm gonna use a kinematic thing. Equals. Okay, so we know our velocity initial equals, what are v cosine theta, v sine theta, minus mass times gravity 0, right? Or that's our velocity? Or, oh god, no.
Isn't that the same thing?
Here we go. Yeah. Yeah, I'm gonna make this comprehensive in a sec. Our final velocity is gonna be v cosine theta 0, 0. Oh gosh. Right?
Yes.
Okay, so that means our average velocity is equal to...
Well, no, our final velocity will have a v sine theta component too.
No, because our final velocity...
Because we haven't technically hit the ground in final velocity.
Yeah, I kinda wanna say we have... Oh my god.
And we get to choose our final velocity, so wouldn't it equal 0 if we want it to? Be the point where it's hitting the ground, it's 0.
Technically, but we're actually looking at the velocity right before we hit the ground because... Wait, why do we need final velocity again?
Oh my god. I'm trying to find a way to work t into this equation.
Oh.
Cause
Well, yeah, so final velocity will have, like... It'll probably be the fastest velocity. It will be equal to initial, technically. But it's like... The block hasn't hit the ground yet. It's just about to.
Why would we do that? Why wouldn't we just make it so it has hit the ground? Like the moment it hits the ground, the velocity becomes 0, and that way we can just solve for time using that, and then divide it by 2.
We could.
Like, is there a specific reason it needs to be right before we've hit the ground?
Generally,
okay.
that's what we treat it as, but if we can adjust it to our case. Because we can define final velocity as whatever we want, but like generally, if you want to talk about final velocity, that's like right before it hits the ground.
I don't even know if we're going in the right direction here. I just know we need to have an equation with t in it that we can plug velocity into. We need to relate velocity and time, and it seems like distance is the only way to do that. Unfortunately, we don't have a distance. If we know our, I mean conceptually we have a starting y velocity, and we have an update. That'd be gravity as our force. So we know, I mean, we can kind of intuit how long it will take for gravity to equal. So it'd be mass times gravity times t, or would it just be gravity times t, whatever, equals v sine theta. And so, yeah, we divide v sine theta by mass gravity, and that'll give us time. But I was trying to find a way to actually get an equation or something like that.
So the momentum principle wouldn't help in this case? Because if your force is just the force of gravity, you can't, that doesn't help you.
I mean, it might. I mean, it actually might. So if we
Because
have...
because you have the initial velocity is v cosine, v sine, and 0. If you times all that by mass, that's p final. Or no, p initial, sorry, I'm screwing up. But you get what I'm saying. Like if you have changed the momentum is equal to f net delta t, you can solve for t, can't you? Or I think.
Yeah, you know what, let's just try it. Let's just try it. Equals plus 0 t. If it's a constant net force, are we supposed to do something different?
No.
Okay. Oh my god. Alright, well this sucks.
Wait, isn't it gonna be net over m delta t? Sorry.
Yeah.
Oh, did I screw up? Mm. No, I think I'm okay. Alright, okay. Maybe.
Equals. Could we do some shenanigans with this to make it look nicer?
Wow.
Where did the sine theta go? Because you have t equals v times sine theta over g. And you set that equal to the velocity over g.
Yeah, you're
Okay,
right.
okay, okay.
So,
just trying
how
to
did
move
g get to
quickly.
the denominator?
Back at this step, I just divided.
Okay, and then
Yeah, I'm still working on this stuff, but I'm trying to simplify
How did
it.
you get from v cosine theta to v sine theta from here?
Here? Okay, so what I did is, from this step, v final is going to be, we know our final velocity at the peak is going to have a y velocity of 0.
Yeah.
And so really I split the vector components into 3 parts, x, y, and z, except x is going to be 0, well, I subtracted v from, to get our delta v.
Oh, okay.
Sorry, so yeah, so I subtracted initial velocity from final velocity to get the change in velocity, and that left me with just a y component of v sine of theta, and that's going to equal f net delta t. F net is just g, and I skipped a couple steps, and here we are.
Okay. I got you.
This is going to be divided by g squared. T equals... we can't do shenanigans. Man. Okay, so ignore this entire step. I'm just going to delete it. Well, what does everyone have?
Are you? Never mind.
was gonna say I got
Sorry,
this.
I'm looking at your work right now.
I was kind of speeding through, so if you see anything.
Looks good, but yeah. Yeah, I don't see anything.
If there's anything wrong at this point, it would all be conceptual. Like, do we have this conceptually wrong? Like, should it be 1/2 FNet or something like that? If we're off by a factor of 1/2, that's going to be real frustrating. But they don't tell us what we did wrong anyway, so.
I think they do. I think they do like recitation videos.
Where?
I just never watched them.
Oh, well.
I think they're on Brightspace.
Well, oh well. So part 3, predict the maximum height. That would just be v sine theta times t. This does not look fun.
Oh wait, but they just square. Like there's 2 square roots, so it's not too bad.
Mm-hmm. Sine theta over g times sine theta?
Yeah, that's good.
K times L0. If our initial step is wrong, all of this is wrong.
You just blame me.
Well, we all get the same grade, so don't
It's
blame
true.
everyone.
They actually grade these anyway.
Why is this? What the heck? Why is it doing this? Sine. Yeah.
They didn't grade our last lab.
Did they not?
Oh, I mean, I don't know. We got 100% though. That sounds fake. So.
Take
On
it
the
from what
last
it's
one?
worth.
Yeah.
Alright,
When we
you
all
take it,
got
I don't
different.
know. Don't worry, we don't have to think about it anymore.
You're still going?
Wait, the one that we just turned in? They graded that?
Yeah.
They
Yeah, lab 7.
You are freaking kidding me.
Good 100%.
So why would they drop your lowest to?
They should drop the lowest 2 homeworks or quizzes or something.
No, because, well, actually, we didn't get 100% on
Oh
one of the
my
labs, like,
God.
2 labs ago.
We got a 23 out of 25 on lab 5.
Mhm.
Lab 7 we got full credit, yeah.
Freaking, word just
100%.
crashed on me. Ugh.
And then all the recitations, we got full credit.
They should drop the Lung Kappa quizzes. I wish they would drop those quiz scores. That would be beautiful.
I think they dropped 1.
I did
Oh,
good
really?
on the first one. Yeah, they dropped my. I did really good on the first 2, but then on this one I didn't really. Yeah. Yeah, they
It was
dropped
not a
it.
good time. It was
we
not a
don't-
good time.
We don't talk about it. It's dropped.
We don't talk about it.
It's forgotten history.
Alright, you guys are gonna have to give me a sec, cause it poopin' crashed on me.
Wait, but if we
Why
have
don't we just copy
v
paste
sine
it?
theta t,
I did what now?
if we have
Hmm?
Elizabeth, what are you saying?
Oh no, I was just asking why I told him he should just copy paste it, and then he did.
Yeah. I mean, I copy
Don't
pasted
forget
the
time
other
for it.
one, so like it wasn't too big of a deal. Why is it doing this to me? There we go.
Why do you have 2 signs? Like, where did they come from? I guess.
One was inherent in T,
I know one's in T, yeah.
and this is the Y component.
Oh. Wait. Oh, okay. I was doing velocity equals distance over time. Let me fix. Oh, height. Okay, got it.
Squared. Don't do this. Word's about to crash again. Ah, it did. Wait, what? I did save though. Okay. So apparently, if you, I can replicate this crash, which is interesting. Just a side tangent, not physics related. So in the equations tab, if you do sine and then an escape character, well, so sine, if you hit space, sine. Yeah, there we go. So, okay, I just got it to crash again. It's probably not a good thing that I'm repeatedly crashing Word on purpose.
Why?
Wait, so sine theta.
So if you,
Word? Hold on, let me try.
no, don't try it. I'm doing this responsibly.
hold on. Sine theta.
Okay, I say that, but
Mine's fine.
well, no. So it depends on how you do it. Where was the? Okay. So what? This is it. This one? Yeah. Yeah. Here we go. So when you type like sine theta, and then if you hit space, notice how it changes. So this is now actually like one character or whatever. So
Okay.
I'm gonna show you again. It's noticeable in that there's a space right here. When I hit space, it fixes itself. So the equations editor does a lot of fancy stuff. So if you do m over g and hit space, it fixes it to like yeah. So if you, before you do that, if you do squared, because if you do like s squared and hit space, it does this, but it doesn't know how to take precedence. So if you do, okay, let me see. Here, so if you do set this up again, if I hit space, I'm thinking it's going to try and put it on top of this, but at the same time, it's supposed to do the sine first, technically, and so it crashes. I don't know the exact reason it crashes, but that's how you replicate it. So, anyway.
I'm not having a problem.
Well, isn't that fantastic?
I'm kind of confused. Okay.
No, it's fine. Sorry, I didn't mean to sound sassy. It is probably just for me. 2 sine.
Good
Sine
hypothesis, though.
theta. Oop. Almost did it again.
Okay,
Cute.
we just, like,
Gah!
simplify things.
God! Dang it! Okay, so turns out I was wrong, and it happens randomly.
Hypothesis is no longer valid.
Well, so you'll have to excuse me while I
Why are you still simplifying that equation?
Yeah, wait,
It's
don't we
time
just
to
have
stop.
don't we
Okay.
just have h equals v sine theta t? Like,
What'd you say?
can we just why can't we
Wait,
just
what's
use
that?
h equals v sine theta t?
Because we need to say what V is, right?
We've already put in V. You're still simplifying it though. Like we have all the information in there.
Yeah, like this is.
Don't we just need h though?
Yeah, yeah. We're simplifying what H is, and it won't. But
Why?
the dream world is that it just turns into like it's the spring constant times 2. It's not, but.
So why is it not v sine theta t?
It is V sine theta t, but what is V? V is this junk, and what is T?
They can just look it up.
T is
It's
this
fine.
junk.
It didn't ask for specific terms.
V is an arbitrary term that we made up, and we have to show that we made it up. So
Yeah, but what's wrong with the H that you have right there?
the H that I have right here.
Yeah.
Well, I noticed that this G would cancel out with this G, and this sign would combine with this sign, and so you would get 2 sine cubed times length, and then you would subtract that from K sine squared. I mean,
Yeah, no, it's like
I just
no,
could. I
yeah,
could
that's
simplify it
hard.
further.
If you really want to, you definitely can. I won't.
Well, apparently I can't because Word keeps crashing.
I'm gonna hold you guys hostage by not doing it,
Okay.
and if you get a bad grade, you'll know why.
Alright, well, I'm just gonna... Part 3... Part 2... Alright, well... Part 1... How confident are we in this?
No.
Slightly.
Nice.
Although
I'm dying.
it
What
happens.
if on the last problem, and like, what if like on the last recitation, we didn't really like drop any, or we still have like one recitation we can drop.
We just
What if
bombed it.
like someone just like write no?
I'm just doodle. Just draw pictures.
Technically, you can stop your teammates. You can just sabotage your team anytime.
Which is why I kind of hate how this is run.
Yeah.
I mean, no offense to you guys,
can
but like,
just
I don't
say-
want my grade dependent on your guys' performance. And you guys shouldn't want your grade dependent on my performance. You should want your
You
grade to
just, like,
reflect how...
sabotage them.
No offense, but I would very much like my grade to be dependent on your grade.
You should want your grade to be a reflection of how well you understand the material. It should not be a reflection on how studious your teammates are and how hard they work.
Well, if you're my teammate, though, I think it's okay.
Yeah,
Doing a
but
good job.
you guys are my teammates.
Sorry.
Carrying the team to victory.
I'm kidding, guys. I'm kidding. Okay, explain the solution. When the object is at the... Oh, wait. Oh, yeah. Peak of the parabolic arc. It's...
What if we just use projectile motion equations? What is it called?
kinematic.
Yeah, what if we just use the kinematic equations because we knew initial velocity.
Yeah, technically this would be a... What? I mean... This is stupid. Momentum equations are kinematic equations, and kinematic equations are momentum equations. They're literally the same thing. It's stupid. So whatever. Okay, so create another problem. What the heck? Watch. Oh, there we go. So, I don't want to be a Debbie Downer, but what the poo? Why is this? Why can't? What is happening? Okay, anyway. Because we weren't entirely confident on part 1, should we do part 2? Sorry, that was I recommend that we do part 2.
I'm fine with doing problem 2. I think it'd be good practice.
Problem
but if
2.
we all really don't want to do it, okay. But I think it would be good practice.
I have time.
Because I struggle with these kind of problems, but that's just me.
How about I have a suggestion.
Okay.
So what if we like talk through it instead of like doing the whole problem?
Well, the
Like,
point
I
of doing
think
the
it's
problem
practice.
is for this qualifier, if you do, you can make up for any points you might lose on problem 1.
Ooh, okay.
This acts as a buffer between points we might lose with whatever the heck these
We
answers
might
are.
lose.
So
And
if we,
I
so
will
it really,
add that.
it's saying if we lose any points, and we did problem 2, and we got the problem right in problem 2, then whatever points we get in problem 2 will be added on to problem 1, up to the maximum. It's like, it's not really extra credit, it's just like a point buffer.
I wish it was extra credit.
It's like half extra credit. It's like the worst kind of extra credit, because you need to run through game theory to wonder if you should do it. So,
Then I would be okay doing it.
we'll see how long
Unless you guys don't want to.
I mean, it's just
One part.
one part maximum, and it's not, there's no numbers, so I'm okay doing it.
Okay, sounds good.
I do hate springs, though. Okay.
Me too. No air resistance.
Do you think they grade these? I don't think they grade these.
Well, we know they don't watch the video.
Yeah, that's true. Also, I'm going to be honest, I don't think I've ever done the second bullet point of this box where it says describe the general strategy you will take to solve the problem.
Yeah, I don't think you have either.
At first it was because I missed it, and now it's just out of principle. I figure out my problems on the fly, gosh dang it, and I don't want to plan ahead. Surroundings, Earth. What?
I said there's no better way to do it.
Earth, spring. Cool. And what is the problem? So, stretches.
Wait, shouldn't we make everything in the system again?
Why?
It matters actually.
I'm doing it. It's too late. Okay. Okay, so F equals kx. We know mass times gravity equals k times what? L A This is weird. When you guys get K, let me know.
Okay, what are we considering to be the equilibrium? Is it just when there's no mass on the spring?
No, the equilibrium, well, it says reference for zero gravitational potential energy is when the mass is on the spring.
Oh, okay. I can't read.
It's okay. Not everyone is literate, and that is okay.
To be fair, I was not done reading the problem.
I don't usually read the problem. What is the maximum compression of the spring? Oh, use the system consisting of the mass spring and Earth. Right. So, you know, if I had...
See if you read the problem.
Yeah, if I had read the problem, I would have... That's really biting me in the butt. Immediately after I said that.
Why didn't you just do K times A? Why did you...
Well, because X is the compression, and the compression, is the distances subtracted from each other, because I'm dumb, that's why. Okay.
You're not dumb. It is an interesting way to do it.
So... Right, so the...
Then we set up energy principle, right? Yeah.
Yeah. Final kinetic 0 minus initial kinetic, which is 1/2.
Wait, why are you saying that? The initial or final kinetic is 0.
The final
wait,
kinetic is...
Never mind.
Okay.
Compression, because yeah, I got you. I'm sorry.
Initial is...
Is the final gravitational potential energy, is that 0, or do I have that wrong?
Okay, what's weird is I think we'll have a negative gravitational potential, but that doesn't make any sense. Give me a sec.
In the initial state, there's going to be no, so it's going to be positive mgh. So it's going to be plus mgh minus 0. Right?
Because if we're considering the equilibrium to be where the mass is just sitting on the spring,
Sorry, what?
wouldn't it be negative because it's initially. Because your final gravitational potential energy, I feel like should be 0, because that's when you're compressing it like all the way and it can't
So
compress more.
So 0 potential energy is when the spring is in phase 2 out of 4 in the diagrams, which means in phase 3 the potential energy would be negative gravitationally, which doesn't intuitively make sense, but hear me out. It would be mass, gravity, height, and height is negative b. So
yeah, that makes sense. Yeah, because you're below equilibrium, so it's negative.
So at phase 4, gravitational potential energy, since it's above equilibrium, would be mgs.
Oh, okay. Yeah, okay.
And both cases have a spring potential energy. One is compressed, the other is stretched. So some signs are going to get flipped. I'm going to need to ask you guys for that because I don't pay attention to signs.
Are we just concerned with... We're just concerned with from phase 2 to phase 3, right? Or is there like another part where we have to worry about?
Phase 2 to phase 3, we're just finding S.
Yeah. That's what I thought. Okay.
Okay. Excuse me. Thank you.
So, for your spring potential energy, like your final and your initial, are they both going to be like values, or is one of them going to be 0?
They're both going to be values.
Okay, that's what I thought. Okay.
So thank God we don't have to solve this.
So is your final spring potential energy, is that 1/2 ks squared? Like the S is, or is that not the right stretch?
Yeah, 1/2 ks squared.
And then your initial is 1/2 kb squared?
Yeah.
Wait, no.
Yeah.
Okay. Okay. Okay.
Yeah.
But you still have S in your. You still have S in your.
Gah! Yeah, you're right.
Yeah.
I'll fix it. Bruh, that doesn't make any sense. What the heck?
Do we have to do quadratic formula?
That wouldn't make any sense, but yeah, I think we might have to. S squared
Can we
plus
just then do the
2as
quadratic formula?
equals minus, okay, AV squared over G minus, plus 2AB plus B squared. Ooh, dang it. Okay. A lot of emotions there. S equals, this is going to be a doozy.
Oh my lord.
Negative 2a plus minus the square root of b squared, so 4a squared minus 4 times plus 4 this divided by 2. All right, what did you guys get?
I've actually been following.
Oh my god, that's why. Okay, never mind. I goofed a little bit. Hang on.
We can simplify this. Isn't that exciting?
No.
Do you say no?
Yes.
If you don't derive joy from simplifying equations, what do you derive joy from?
Not simplifying equations and still getting the right answer.
Well, aren't you special? This is gonna be such a lame simplification, by the way. Don't crash on me. Word's chugging along, but it's not doing too hot. All right. Oh, and we're gonna. There we go. Does this even make sense?
No. 1 second. Where did you get the 2A? S.
2a.
Is it plus or minus?
Yeah. And 2as.
Multiplied everything by 2.
Sorry, I did what?
You multiplied everything by 2A.
Yes.
Did you?
I multiplied everything by 2a divided by mg.
Why?
And
No.
that is a good question. I think it would be. I think it would be plus.
Okay. No. I think it's negative.
Why?
Well, you're compressing the string, right? So
Okay.
Actually, no. Because it's L minus... No, it's L naught minus L final. Or L, like your actual length. So it's negative. I don't know. But you want a positive force. Because it's like pushing, or it's trying to extend.
Well, guys, what do you think?
Trying to figure out where I went wrong.
Okay.
Because I didn't plug in MG over A for K. I just let K be K, and then I put it into the thing at the end. So everything looks a little bit different.
Keep in mind, I could have done something wrong. If I did, I'm going to be very sad. So no one pointed out.
Okay. I think it needs to be a plus and not a minus.
Alright, that's the answer. Cool, we'll move on. It's all resting on you now.
Have a good day.
I'm trusting on that.
Wait, is that it?
Well, we gotta,
wait, you gotta switch to the problem.
yeah, we gotta.
Oh wait,
Paste
hold
this
on.
in for the
I
intro.
actually almost submitted that.
I'm about to. Justify our solution. I don't know. It just works, man.
We just think it's right.
We use the energy principle, so it has to be right.
I'm just gonna say energy is conserved. So the potential energies equal. The final energies equal the initial energies. You can solve for us. Easy peasy. Are there other ways to solve this problem? No. Because we're awesome.
Absolutely not.
Create another problem in a different context. How about
The opposite.
There's 4
Like,
springs. Or 5
How long
springs.
will it extend?
vertical spring with a block placed on it? You stretch it and let go. Boom. What's the max compression? Easy
Isn't that
peasy.
the same question?
No,
The new one is flipped it
extension.
vertically.
Oh.
Because these are hanging down, I flipped it and went up. So it would be it would be positive. Gee, I hope we got all the signs right.
Let's hope so.
Well, we get 2 tries.
Good thing they don't actually grade these.
Yeah, right. So evil. Yeah, so good job, guys. I'm gonna stop recording.